So we're just going to do a little tear down of the Catalinbread Belle Epoch or Epoch. When the Belle Epoch and Echo Rec came out, I think they were probably around 2013 or so. They're quite old now, but really good pedals. The way that they were marketed by Catalinbread, and I think both of them are mainly designed by Jack DeVille and I guess Howard G as well. I don't know who played a major role, but I mean Jack's name is on the PCB, as we'll see later. And yeah, the interesting pedal to have a look at, because I think it's good for smaller builders and DIY guys to see how they build these, because it's not really, there's nothing really out of reach of the average builder. It's FV1 based. None of the parts are hard to obtain. The enclosure is a bit of a custom job, but yeah, we'll also take a look at just some of the design choices that a larger company like Catalinbread makes when they build a pedal like this. The graphic, I guess it's you can feel the text. It's like a nice kind of 3D. I do think it's a tasteful graphic. It's not too over the top like some of the Electro Harmonix ones. It keeps in line with the branding of the original Echoplex delays, the actual tape versions. First thing to note is we've got just a nice circular drill point for that board mounted jack. Electro Harmonix managed to get an actual rectangle shape cut out on theirs at the top, I think, these days, which looks a bit nicer. Anyone can do this, but getting it actually, that's probably my main critique of this build quality, is that you've got big gaps in the enclosure there, which doesn't look the best. And then other than that, 9 to 18 volt DC. I find that the 18 volt thing makes a bigger difference for the dirty little secret pedal that they make, the Marshall Inner Box. For the Belle, I really don't notice much difference at 9 or 18 volts. In fact, it seems like there's a little bit of additional noise at 18, so I think I prefer this one at 9 or 12. They use standard push fit knobs, which I think is a pretty good choice. On my pedals at the moment, I use ones that have a thread. Oh, come on, just focus. So I use ones with this sort of threaded screw, but these can come loose on the pot, and then not every person is going to be able to fix that on their own, which is, not something you want from a company perspective. Whereas ones like this, if they do happen to come loose, you can just gently kind of widen the spacing with a flathead screwdriver of the top shaft of the pot, and then you'll get a tight fit. But I mean, I've never really had these come loose, and it's much faster in build time, easier to get them nicely aligned at the factory. The other thing, that LED bezel, it's just standard one like this. So these are easy. I buy these from Teardown Electronics. They're very cheap, and a lot of builders use these. They're sort of quite standard. The only thing is, you got to get the hole just right if you want it to wedge in nicely, or you can use a bit of super glue, but then you are left with a permanent fixing. They do actually kind of friction mount in there if you get the hole drilled just perfect. So I'm going to use my trusty do-it-all Leatherman tool to start taking it all apart. Try not to scratch it too much. I did buy this used, so I'm not super worried about keeping it pristine. There's already some scratches on it when I got it. So you will see guys on certain forums talking about board mounted jacks and switches. In this case, I mean, it's rare to see board mounted pots, jacks and switches, but it can be done. In this particular case, it's only the foot switch and the jacks. It's only really a problem if the side walls of the enclosure are angled. When they're straight like this, I don't think, you're not putting too much force on the PCB, or if the retaining nut on the foot switch below on the inside of the enclosure comes loose, you can be kind of pushing the PCB, but I honestly wouldn't worry about it that much. Pedals like this tend to get used, you know, on desks and in people's bedrooms more often than on the dance floor or the, you know, the stage these days. I don't know why I said dance floor. Alright, so let's take a look at the circuit board. Get that nice and focused for you. So it looks pretty good to me. Obviously, I believe, you know, they'd use non-leaded solder, standard these days. It's done quite well. There's a few burn marks here and there, a little bit there, a little bit around there, where it just maybe indicates that it got a little bit warm during production, but overall it does, you know, it's pretty nice quality PCB and well laid out. Nice to have, you know, company indentation in the enclosure. So they've obviously, as we'll see, I mean, I've seen this already, but they don't make them in-house as far as I can tell. The company is written on the inside of the top portion of the enclosure. We can just push that out now. There we go. So OEP Inc. and it's their LK1590B enclosure. So we'll just have a look at this company. So OEP, I think they're based in China. It looks all quite legitimate. They make, you know, control knobs, music equipment components. So here's their enclosures, LK1590B. So it's obviously not like a customer sort of site. I mean, it's not, it's a, you know, it's a commercial sort of ordering site, so I imagine that you'll send them an email and then go from there in that sort of way, rather than just, you know, buy it now from the website. And, you know, they've made some sort of arrangement, I guess, with Catalinbread to, you know, produce X number of enclosures, some large number, and then they can get, you know, custom branding, and perhaps I don't know if, you know, OEP does the base coating as well. The other thing there, they've got, this is, you know, it was all kind of surprisingly labor intensive for a large scale production pedal. That scratching off of the paint, you know, someone's going to do that by hand. That's where they have their little ground spring here. They've got 3, you know, large solder contacts for that there, just to ground the enclosure. But, you know, there's a lot of things I don't know about the design choices with this. So looking at the board, you know, standard pots, those are obviously wired to the board by hand using, I imagine, regular braided wire. They wouldn't use solid core, even though the wires do feel quite rigid. And we've got a Pity the Fool inscription on there. And here we have PCB by Jack DeVille. Maybe Howard did the coding, I'm not too sure, though Jack does that sort of thing as well. So we got Neutrik or Neutrik jacks, and I always find this cool. So, you know, they basically just space them exactly so that they flush fit into the side walls of the enclosure there, and then from the outside the nut just you know, grabs in, and it doesn't have to be all the way in for the input jack to, you know, go in properly. So you can obviously have that extra space for the enclosure wall. Got our DC jack there. That's our true bypass and buffered bypass switch there. And we've got our FV1 chip in there. I'll try and get a good angle on that. That's just the spin FV1, which is quite commonplace in sort of boutique digital pedals. So that, you know, that's used for them to basically make their tape delay sound. The other chip that is in here is this one, which is, I did read it yesterday, if I can, let's move that out of the way, there we go. So we've got PIC 16F506. I don't know what that's used for. I think it's used for some, maybe making, I've heard it can be used as a bit crusher, so I don't know if it's used to kind of make the sound more lo-fi or if it's used for like program changes. I'm not too sure. Someone else could maybe answer that in the comments. Other thing that's interesting, I'm not sure if they just use regular heat shrink or they buy some custom fit heat shrink for these two parts, or just so they don't short out against the adjacent ones when they're in the enclosure or underneath. But yeah, that is interesting. You can also see some empty spaces because I think they use the same PCB for the Echo Rec and perhaps some of the other delay pedals that they make. So we'll put this back together now and do a bit more investigation. The only other thing I was going to say about the enclosure is, I mean, you can see compared to, this is a standard, I think 1590 style enclosure. And, you know, these are kind of, the Catalinbread one, it's quite elegant, you know, it's not as chunky. Even with the bass on there, you know, it's quite a lot less chunky than standard 1590. So what we're doing now is just running a 1000 hertz sine wave through the Belle. It's bypass at the moment, and it's coming back in on a return track here. So we'll bring up an EQ just so we can see what's happening. Might have to stop recording for that. Okay, got that working now. So you can see we've got our 1K sine wave here. It's in bypass. So I think I've got the pedal set to a slight boost when switched on. We've got the mix at 0 though. So there's your slight boost. And if we put the mix all the way up, we can see the record level's right down, so we do get a lower signal there. But you can see as you bring that up, the record level, you see the extra distortion there, extra harmonics indicating that. If we give it maybe just a slightly lower frequency to make this a bit clearer, it's a bit nicer. And we can also have a look at the modulation, see what that's doing. So you can see that just wiggling there, fairly standard stuff. If we activate the what they call Easter egg vibrato mode, just by powering it back up with the modulation set to max, we can see a much faster rate of modulation on there. And I believe lowering the knob just reduces the depth, but the rate stays constant there. You can see, yeah, so you can see how it kind of appears to widen on the frequency analyzer, but it's really just probably not keeping up with the speed of that modulation to represent it in full. So let's have a look at this 9 to 18 volts thing. We leave it set like that. That's running at 9 volts at the moment. I'm going to switch it over to 18. I don't think we're going to see much. Actually, I'll bring this just up to, so we can't quite hit 10 there. All right, let's hit 20 then. Negative 20, I guess. Right there. So we should be able to perceive a difference there. Now we're at 18 volts. To me, that looks exactly the same. Could try some white noise instead. Don't see a world of difference. If we put the mix to 0, switching to 18 now, it looks the same to me. And we'll just go back to the sine wave as well. So we're on about 15, negative 15 dB. Go back to 9. And yeah, not a lot of difference there. We could also turn up the signal level. So we're just, we're seeing the pedal is clipping there, and that's at 9 volts. We'll see if we get the same sort of number of harmonics and size of those. Okay, there's the difference. That's interesting. That's at 18 now. We don't have that clipping showing, whereas we go back to 9, and you can see it right there. It is clipping at 9. So yeah, that's pretty cool. You get more headroom for sure at 18 volts. You can see that right there. And if we go to 12 volts, yeah, so we just get over. Okay, let's make it clip at 12 volts. Just there. And now let's go to 18. So those two are pretty similar. And now 9, and there's your clipping again.